Let's look at that in a little more detail from the perspective of the process. So we have the parent process running at this particular host, and it's trying to reach some server process running at this other host on port 80. So the client process will, using system calls, send a particular payload to that host. That payload is combined with a particular address as it's sent to the kernel. The kernel will assemble the payload with a packet header to say where this data is meant to be sent to. So you see the packet header is going to have information about where this packet is meant to be delivered. It'll also say where that packet is coming from. So if this was our Firefox process and it was sending through port number 7365, that's included in the packet so that ultimately responses will, the other end will know where it came from and know where to send responses. The kernel takes that information and it sends it out to a network interface controller. For example, it sends it to the Ethernet card, which has some software that connects to the device and sends things out over the network. So if it's an Ethernet card, it's probably attached to, it's attached to an Ethernet wire ultimately, which is attached to some other machines, and we can just abstract over that machines and say there's a router that maybe has multiple network cards, so it can get information from different entry points, and then multiple network cards on the other ends that it's routing things to. So once this packet is sent by the kernel through the network interface controller, it gets another header, say if this is Ethernet, that addresses, that says this packet is meant to go to the router on this network, which is identified by a MAC address. The details are not too important, but suffice to say that there are these layerings that happen to get a packet from one place to another. We start with the payload, we put some address information, that is the IP protocol, and then that gets some extra headers, that is the Ethernet protocol. The router then, this piece of software here, looks at the IP headers and decides which network to send it back out of. In this case, it needs to send it out through this network, and it gives a new address to say it needs to be going to this machine because it knows that machine is the one to get these kinds of packets. That network interface controller on the receiving side will then strip off the Ethernet part, leaving the IP part intact, which goes to the kernel, which knows that port 80 is being used by a particular server process on this machine in this OS, and so it takes the payload and delivers it to that server process. So that, from a 1,000-foot view, is how things work. This router in between these two networks has the possibility of thinking of different addresses on either side of it. And in particular, in your home network, you probably have a NAT router that sits between your home machines and the rest of the world. And with a NAT router, you think your client process on your machine thinks your machine has some address, maybe 192.168.100, and that goes out to your home router, where it not only knows where it should go to get to 129.10.116.81, it knows go out of the house, but as it sends that through to the other network, it also has the opportunity to update the header. Because from outside of the house, this address is not the real address to get back. Instead, your home's router, say your cable modem or something like that, has a particular address to the outside world. So routers often manipulate this packet information to change the headers so that when the server wants to respond, it knows to respond to that particular machine, which goes back to the NAT router. The NAT router has to keep track of the fact that 7365, the port, TCP port 7365, as it receives anything intended for that port, then it has to rewrite it to a different address and port corresponding to what things look like on the home side. So that's a small example of the kinds of things that routers do to bridge networks and have different internal and external views of addresses. For the most part, we will ignore that layer and just imagine that when we're contacting a particular address, it's a globally known and unique address.